Hey, altruistic followers and constructive critics, are you and your beloved fine and dandy? It's activist cum preacher Professor S. Suresh back with absolute delight for my 60-second video in pipeline for publication on YouTube today, 14th of August 2020. Topic for discussion today is industrial engineering techniques and its applications. Industrial engineering is an engineering profession that is concerned with the optimization of complex processes, systems or organizations by developing, improving and implementing integrated systems of people, money, knowledge, information, equipment, energy and materials. Industrial engineers use specialized knowledge and skills in the mathematical, physical and social sciences together with the principles and methods of engineering analysis and design to specify, predict and evaluate the results obtained from systems and processes. From these results they are able to create new systems, processes or situations for the useful coordination of labor, materials and machines, and also improve the quality and productivity of systems, physical or social. Depending on the sub-specialities involved, industrial engineering may also overlap with operations research, systems engineering, manufacturing engineering, production engineering, supply chain engineering, management science, management engineering, financial engineering, ergonomics or human factors engineering, safety engineering or others, depending on the viewpoint or motives of the user. There is a general consensus among historians that the roots of the industrial engineering profession date back to the Industrial Revolution. The technologies that helped mechanize traditional manual operations in the textile industry, including the flying shuttle, the spinning jenny, and perhaps most importantly the steam engine, generated economies of scale that made mass production in centralized locations attractive for the first time. The concept of the production system had its genesis in the factories created by these innovations. Adam Smith's concepts of division of labor and the invisible hand of capitalism introduced in his treatise The Wealth of Nations motivated many of the technological innovators of the Industrial Revolution to establish and implement factory systems. The efforts of James Watt and Matthew Boulton led to the first integrated machine manufacturing facility in the world, including the implementation of concepts such as cost control systems to reduce waste and increase productivity, and the institution of skills training for craftsmen. Charles Babbage became associated with industrial engineering because of the concepts he introduced in his book on the economy of machinery and manufacturers, which he wrote as a result of his visits to factories in England and the United States in the early 1800s. The book includes subjects such as the time required to perform a specific task, the effects of subdividing tasks into smaller and less detailed elements, and the advantages to be gained from repetitive tasks. Frederick Taylor is generally credited as being the father of the industrial engineering discipline, father of scientific management also. He earned a degree in mechanical engineering from Stevens University and earned several patents for his innovations. His books Shop Management and the Principles of Scientific Management, which were published in the early 1900s, were the beginning of industrial engineering. Improvements in work efficiency under his methods were based on improving work methods, developing of work standards and reduction in time required to carry out the work. With an abiding faith in the scientific method, Taylor's contribution to time study sought a high level of precision and predictability for manual tasks. The husband and wife team of Frank Gilbreth and Lillian Gilbreth was the other cornerstone of the industrial engineering movement, whose work is housed at Purdue University School of Industrial Engineering. They categorize elements of human motions into 18 basic elements called thermalics. It's Gilbreth spelled backwards actually. This development permitted analysts to design jobs without knowledge of the time required to do a job. These developments were the beginning of a much broader field known as human factors or ergonomics. In 1908, the first course on industrial engineering was offered as an elective at Pennsylvania State University, which became a separate program in 1909 through the efforts of Hugo Daimer. The first doctoral degree in industrial engineering was awarded in 1933 by Cornell University. In 1912, Henry Lawrence Gantt developed the Gantt chart, which outlines actions of the organization along with their relationships. This chart opens later form familiar to us today by Wallace Clerk. With the development of assembly lines, the factory of Henry Ford accounted for a significant leap forward in the field. Ford reduced the assembly time of a car more than 700 hours to 1.5 hours. In addition, he was a pioneer of the company of the capitalist welfare capitalism and the flag of providing financial incentives for employees to increase productivity. In 1927, the then Technics Hochschule Berlin was the first German university to introduce the degree. The course of studies developed by Willy Pryan was then still called Business and Technology and was intended to provide descendants of industrialists with an adequate education. Comprehensive Quality Management System, TQM, Total Quality Management, developed in the 40s, was gaining momentum after World War II and was part of the recovery of Japan after the war. The American Institute of Industrial Engineering was formed in 1948. The early work of F.W. Taylor and the Gilbreths was documented in papers presented to the American Society of Mechanical Engineers, ASME, as interest grew from merely improving machine performance to the performance of the overall manufacturing process. Most notably, starting with the presentation by Henry R. Town of his paper, The Engineer as an Economist, in the 1960 to 75, with the development of decision support systems in supply, such as the Material Requirements Planning, MRP, one can emphasize the timing issue of industrial organization. Israeli scientist Dr. Jacob Rubinovitz installed the CMMS program developed in IAI and control data, Israel in 1976 in South Africa and worldwide. In the 70s, with the penetration of Japanese management theories such as Kaizen and Kanban, Japan realized very high levels of quality and productivity. These theories improved issues of quality, delivery time, and flexibility. Companies in the West realized the great impact of Kaizen and started implementing their own continuous improvement programs. In the 90s, following the global industry globalization process, the emphasis was in supply chain management and customer-oriented business process design. Theory of constraints developed by an Israeli scientist, Eli Hago, M. Goldratt, is also a significant milestone in the field in 1985. Engineering is traditionally decompositional. To understand the whole, it is first broken into parts. One then masters the parts and puts them back together, becoming the master of the whole. Industrial and systems engineering approach is the opposite. Any one part cannot be understood without the context of the whole. Changes in one part affect the whole, and the role of a part is a projection of it into the whole. In traditional engineering, people understand the parts first and then they can understand the whole. In ISE, Industrial and Systems Engineering, they understand the whole first and then they can understand the role of each part. Reverse. Also, industrial engineering considers the human factor and its relation to the technical aspect of the situation and all the other factors that influence the entire situation, while other engineering disciplines focus on the design of inanimate objects. Industrial engineers integrate combinations of people, information, materials, and equipment that produce innovative and efficient organization. In addition to manufacturing, industrial engineers work and consult in every industry, including hospitals, communication, e-commerce, entertainment, government, finance, food, pharmaceuticals, semiconductors, sports, insurance, sales, accounting, banking, travel, and transportation. Industrial engineering is a branch of engineering most closely related to human resources, in that we apply social skills with all types of employees, from engineers to salespeople to top management. One of the main focuses of an industrial engineer is to improve the working environments of people, not to change the worker but to change the workplace. They are change masters. All engineers, including industrial engineers, take mathematics through calculus and differential equations. Industrial engineering is different in that it is based on discrete variable math, whereas all other engineering is based on continuous variable math. We emphasize the use of linear algebra and differential equations as opposed to the use of differential equations, which are so prevalent in other engineering disciplines. This emphasis becomes evident in optimization of production systems, in which we are sequencing orders, scheduling batches, determining the number of materials handling units, arranging factory layouts, finding sequences of motions, etc. As industrial engineers, we deal almost exclusively with the systems of discrete components. While originally applied to manufacturing, the use of industrial engineering can be somewhat misleading, since it has grown to encompass any methodical or quantitative approach to optimizing how a process, system, or organization operates. In fact, the industrial engineering means the industry in its broadest sense. People have changed the term industrial to broader terms such as industrial and manufacturing engineering, industrial and systems engineering, industrial engineering and operations research, industrial engineering and management. Industrial engineering has many sub-disciplines. Although there are industrial engineers who focus exclusively on one of these sub-disciplines, many deal with a combination of them, such as supply chain and logistics, and facilities and energy management. The various fields and topics that industrial engineers are involved, which include manufacturing engineering, engineering management, process engineering, design, operation, control and optimization of chemical, physical and biological process, systems engineering, and interdisciplinary field of engineering that focuses on how to design and manage complex engineering systems over their life cycles. Software engineering, an interdisciplinary field of engineering that focuses on design, development, maintenance, testing and evaluation of the software that make computers or other devices containing software work. Safety engineering, an engineering discipline which assures that engineered systems provide acceptable levels of safety. Data science, a science of exploring, manipulating, analyzing and visualizing data to derive useful insights and conclusions. Machine learning, the automation of learning from data using models and algorithms. Analytics and data mining, the discovery, interpretation of and extraction of patterns and insights from large quantities of data. Cost engineering, practice devoted to the management of project cost involving such activities versus as cost and control, estimating, which is cost control and cost forecasting, investment appraisal and risk analysis. Value engineering, a systematic method to improve the value of goods or products and services by using examination of function. Predetermined motion time system, PMTS. A technique to quantify time required for repetitive tasks. Quality engineering, a way of preventing mistakes or defects in manufactured products and avoiding problems when delivering solutions or services to customers. Project management is a process and activity of planning, organizing, motivating and controlling resources, procedures and protocols to achieve specific goals in scientific or daily problems. Supply chain management, the management of the flow of goods. It includes movement and storage of raw materials, work in process inventory and finished goods from point of origin to point of consumption. Ergonomics, the practice of designing product systems or process to take proper account of the interaction between them and people that use them. Operations research, also known as resource management techniques or management science, discipline that deals with the application of advanced analytical methods to help make better decisions. Optimizing operations. Operations management, an area of management concerned with overseeing, designing and controlling the process of production and redesigning business operations in the production of goods or services. Job design, the specification of contents, methods and relationship of jobs in order to satisfy technological and organizational requirements as well as the social and personal requirements of the job holder. Financial engineering, the application of technical methods especially from mathematical, finance and computational finance in the practice of finance. Industrial plant configuration, sizing of necessary infrastructure used in support and maintenance of a given facility. Facility management, an interdisciplinary field devoted to the coordination of space, infrastructure, people and organization. Engineering design process, formulation of a plan to help an engineer build a product with a specified performance goal. Logistics, the management of the flow of goods between the point of origin and the point of consumption in order to meet some requirements of customers and corporations. Accounting, the measurement, processing and communication of financial information about economic entities. Capital projects, the management of activities in capital projects involves the flow of resources or inputs as they are transformed into outputs. Many of the tools and techniques, principles of industrial engineering can be applied to the configuration of work activities within a project. The application of industrial engineering and operations management concepts and techniques to the execution of projects has thus been referred as project production management. Traditionally, a major aspect of industrial engineering was planning the layouts of factories and designing assembly lines and other manufacturing paradigms. And now the lean manufacturing systems. Industrial engineers work to eliminate waste of time, money, materials, energy and other resources, called as MUDA in Japanese. Examples of where industrial engineering might be used include flow process charting, process mapping, designing an assembly workstation, strategizing for various operational logistics, consulting as an efficiency expert, developing a new financial algorithm or loan system for a bank, streamlining operation in emergency room location or usage in hospital, planning complex distribution schemes for materials or products, and shortening lines at a bank, hospital or a theme park. Modern industrial engineers typically use predetermined motion time systems, computer simulation, especially discrete event simulation, along with extensive mathematical tools for modeling such as mathematical optimization and queuing theory and computational methods for system analysis, evaluation, and optimization. Industrial engineers also use the tools of data science and machine learning in their work, owing to the strong relatedness of these disciplines with the field and the similar technical background required of industrial engineers. In probability theory, linear algebra and statistics, as well as coding skills, the human factors area specializes in exploring how systems fit the people who must operate them, determining the roles of people with the systems, and selecting those people who can best fit particular roles within the system. Students who focus on human factors will be able to work with a multidisciplinary team of faculty with strengths in understanding cognitive behavior as it relates to automation, air and ground transportation, medical studies, and space exploration. The production systems area develops new solutions in areas such as engineering design, supply chain management, manufacturing, and medicine. Students who focus on production systems will be able to work on topics related to computational intelligence theories for applications in industry, healthcare, and service organizations. Biomanufacturing is our most recent research addition. The objective of the reliability systems area is to provide students with advanced data analysis and decision making techniques that will improve quality and reliability of complex systems. Students who focus on system reliability and uncertainty will be able to work on areas related to contemporary reliability systems, including integration of quality and reliability, simultaneous life cycle design for manufacturing systems, decision theory in quality and reliability engineering, condition-based maintenance and degradation modeling, discrete event simulation, and decision analysis. The wind power management program aims at meeting the emerging needs for graduating professionals involved in design, operations, and management of wind farms deployed in massive numbers all over the country. The graduates will be able to fully understand the system and management issues of wind farms and their interactions with alternate and conventional power generation systems. Industrial engineers study the interaction of human beings with the machines, materials, information, procedures, and environments in such developments and in designing a technological system. Universities offer degrees at the bachelor, master's, and doctoral level. As mentioned before, industrial and production engineering (IPE) is an interdisciplinary engineering discipline that includes manufacturing technology, engineering sciences, management science, and optimization of complex process systems or organization. It is concerned with the understanding and application of engineering procedures in manufacturing process and production methods. Industrial engineering dates back all the way to Industrial Revolution, initiated in 1700s by Sir Adam Smith, Henry Ford, Eli Whitney, Frank Gilbreth and Lillian Gilbreth, Henry Grant, F.W. Trader, Frederick Winslow Taylor, etc. After the 1970s, industrial and production engineering developed worldwide and started widely used automation and robotics. IPE includes three areas: mechanical engineering, industrial engineering, and management science. Production engineering originated from mechanical, even manufacturing. The objective is to improve efficiency, drive up effectiveness of manufacturing, quality control, and reduce cost while making the products more attractive and marketable. Industrial engineering is concerned with the development, improvement, and implementation of integrated systems of people, money, knowledge, information, equipment, energy, materials, as well as analysis and synthesis. The principles of IPE include mathematical, physical, and social sciences and methods of engineering design to specify, predict, and evaluate the results to be obtained from the systems or process currently in place or being developed. The target of production engineering is to complete the production process in the smoothest, most judicious, and most economic way. Production engineering also overlaps substantially with the manufacturing engineering and industrial engineering. The concept of production engineering is interchangeable with manufacturing engineering. Modern manufacturing engineering studies include all intermediate process required for the production and integration of products components. Some industries such as semiconductor and steel manufacturers use the term fabrication for these processes. Automation is used in different processes of manufacturing such as machining and welding. Automated manufacturing refers to the application of automation to produce goods in a factory. The main advantages of automated manufacturing for the manufacturing process are realized with the effective implementation of automation and include higher consistency and quality, reduction of lead time, simplification of production, reduced handling, improved workflow, and improved worker morale. Industrial engineers play multiple roles in industries: supply chain management, productivity methods and process engineering, quality measurement and improvement, program management, ergonomics, also known as human factors engineering and man-machine systems, technology development and transfer, strategic planning and management of change, financial engineering. Some techniques utilized by industrial engineers: benchmarking, design of experiments, employee involvement, equipment utilization, flow diagramming, information and data flow diagramming, interviewing for information, lean manufacturing, modeling and testing, operations auditing, organizational analysis, pilot programs, plant and equipment layout, project management, simulation, Six Sigma projects, statistical analysis, strategic planning, theory of constraints, time studies, work sampling. The term industrial and industrial engineering can be misleading. While the term was originally linked with manufacturing, it has grown to encompass virtually all other businesses and services. Contrary to other engineering specialties which are dealing with the products and process, industrial engineering is closely linked with the management and business administration of materials and manpower in manufacturing environment. The industrial engineers serve as a bridge between management in a goals and operational performance. They combine a solid engineering background with a good business sense and management ability to integrate knowledge, employees, equipment, materials, energy and information into productive units. It also deals with the designing new prototypes to help save money and make the outgoing products better. Industrial engineering draws upon the principles and methods of engineering analysis and synthesis, as well as mathematical, physical and social sciences, together with the principles and methods of engineering analysis and design to specify, predict and evaluate the results to be obtained from such systems. Finally, it is associated and it deals with the efficient management of money, respecting a marketing strategy in order to make the best use of available resources and to lower costs, while improving quality and increasing safety, and in good practice sense of the formula, performance is equal to results by cost. Curricula for an industrial engineering degree must be designed to afford to the graduates quite good knowledge about materials involved in the specific process, professional background in manufacturing technology with a specificity on the domain, associated and innovative thinking, the capacity to observe others and understand why they are doing what they do in order to make the proper changes at the workplace, reliability and flexibility of professional behavior for complex equipment, new materials and workers training, availability to develop new solutions for materials handling and mechanization, projects, prototypes for suitable plant layouts, improving the efficiency of the production systems unit to handle the modern engineering methods and tools in order to eliminate waste of time, money, materials, energy and other resources, lean manufacturing, Kanban, JIT, just-in-time systems, MRP, material requirement planning, ERP, enterprise resource planning, TPM, total productive maintenance, OEE, overall equipment effectiveness, CAD/CAM, computer-aided design, manufacturing model and simulation software, FMECA, failure mode effects and criticality analysis, capability to focus on the big picture, basically organized, specialized in manufacturing technologies, industrial design and resources management. They must also be capable of to manage major manufacturing systems. Industrial engineers must be an active and innovative person, a systems integrator, and champions of change. The ability to communicate effectively, high professional ethics, the responsibility and ability to interact with the groups of individuals in different environments in order to earn respect, to have their ideas considered and not at last to sell their ideas. Working on problems of systems which include human resource management as a major variable. Industrial engineering is the most people-oriented area in engineering, particularly green product-oriented thinking skills. By this time, all of you would have realized the fact that industrial engineers are versatile, innovative to the core, can play multiple roles and are an indispensable asset for all types of organization, whether it is manufacturing or service or hybrid. Change is the only constant in real life. Industrial engineers are the change masters, stimulants, instruments, key for changes for all kinds of improvements, whether it pertains to quality, productivity, optimization, profit, revenue, value engineering and cost reduction. Debates and discussion on topics like this can go on forever. Anyhow, let me call it a day. We'll meet again real soon. Some of the statements, views expressed are solely mine, based on limited knowledge gained over 6 decades. Always watch these videos with the subtitles for absolute 100% comprehension as per my sincere recommendation zillion times so far. I know I rushed through to complete the presentation within 20 minutes max. It's not possible nowadays since I exceed this time limit, since I make honest attempts to cover the selected topics more elaborately, including so many intricate details, referring a wide variety of the sources, in particular Wikipedia, quite extensively besides articles and books published recently. In addition, I add my own salt and pepper and masala based on my personal experiences so far in my life and also intuition. Stay at home as much as possible to maintain social distancing attributed to pandemic novel COVID-19 and prolong your lifespan. All the best. Rest in peace and harmony.